Welcome to a new lesson. Using the tangent ratio to calculate lengths. Let's take a look at an example. Given the following triangle, determine the length of AB to the nearest tenth of a centimeter. Let's write down the tan ratio equation. So we have tan of an angle is equal to opposite over adjacent. Now let's talk about the angle that we have in this picture. We have the angle 30, which is angle C. But the first thing we have to do is label the specific sides. We know that the angle that faces, the side that faces this angle is called the opposite side. We know the longest side in the triangle, which faces the 90 degrees, is called the hypotenuse. And the remaining side, which also touches the 30-degree angle, is called the adjacent. So we're going to use the opposite and the adjacent to find the value of the opposite side. In this case, defined by the question AB. So we're going to find this missing opposite side, because that's what the question asks. So let's plug in the information that we know. So we know that it is tan of 30 degrees is equivalent to the missing side, which is opposite, over the adjacent side, which is tan. To make it a little bit easier, I'm going to draw the opposite side, or O, not 0, O, with orange color. The next step is to isolate for this opposite side by looking at the tan. The tan is divisible. So what we need to do is we have to do the opposite of division, which is multiplication. And if we multiply one side by 10, we multiply the other by 10. Why do we multiply? Because of this simple truth. When we multiply 10 and then divide by 10, the answer is 1. It cancels out. And on the left-hand side, we're going to have 10 tan 30 is equal to the opposite side. On your calculators, don't forget that your mode has to be switched to degree mode, DEG, in order for your answer to come true. So therefore the opposite side is 5.8 centimeters. That's your opposite side, or side AB of the triangle. Notice that you have to be careful that we are rounding to nearest tenth. Let's take a look at a different question. Determine the length of EF to the nearest tenth of a centimeter. So EF is located right here. That's your EF. Again, let's write the trig equation. Trig of an angle is equal to opposite over adjacent. And the one angle that we know of is 20. It looks at the opposite side. So we are labeling the triangle. We know the hypotenuse side is face or opposite to 90 degrees. So that's the hypotenuse. And the remaining side that we're looking for, EF, is called the adjacent side. We do not know the adjacent side of the triangle. Again, this is all with respect to the 20-degree angle, which we call F. So let's plug in what we know and we do not know into this tan equation. So we know that tan is 20. And the opposite side we also know, which is 3.5, but we do not know this adjacent side. And I'm just going to draw it in orange for you. In order to solve for the adjacent side, we're going to use the rules of cross multiplication. That's one way to solve for A. The rules of cross multiplication states that you can cross multiply or move the tan 20 from the left side of the equation to the right side of the equation, but we have to change from numerator to denominator. This means that the tan will appear in the denominator of the fraction on the right hand side. While on the other hand, the adjacent side can move diagonally across or cross into the numerator of the left hand side. Now we could solve for our missing adjacent side. Plug this in your calculator, put brackets around the 20, make sure in degree mode, and the answer is to the nearest tenth of a centimeter of 9.6 centimeters is your answer. Let's take a look at a different question. A searchlight beam shines vertically on a cloud at a horizontal distance of 250 meters. From the searchlight, the angle between the ground and the line of sight to the cloud is 75 degrees. Determine the height of the cloud to the nearest meter. So let's take a look at this picture. We know it's 75 degrees, and the horizontal distance from the searchlight is 250 meters. So where is that 250 meters? 250 meters is this distance right here. Let's again write the tan ratio. The tan over the angle is opposite over adjacent. Let's label it with respect to this angle of 75. We know the opposite side is called the opposite, obviously. And the longest side, which is at opposite to 90 degrees, and I'm just going to draw it right here, is the hypotenuse. That's not the height. That's the hypotenuse, the longest side of the triangle. So the missing side, or the 250 meters side, is the adjacent side of the triangle. And in this question, we're trying to find the height basically to the cloud from the ground. Well, what we are looking for is the opposite side of the triangle. The height is always the perpendicular distance from the ground straight up. So let's plug into our tan equation all the information that we know. We're looking for the opposite side, and I'm just going to draw it in green in this case. And we know the adjacent side, which is 250. So let's solve this by cross multiplication. We're going to cross multiply. That means we're going to move the 250 from one side of the equation to the other. But now we could put it on top. And that is equal to the opposite side, which is our height. You plug this in your calculator, make sure you have brackets around 75, and using degree mode, we'll get the answer of 933 meters. That is the height of the cloud.